Hi guys, this video is going to take you through 9.1 to 9.3's test review. We'll go over some general concepts and then I'll go through and work out some examples. So 9.1 was circles and parabolas. We're going to start with the circles, which is the one we've probably done the most this year. So standard form of a circle is x minus h squared plus y minus k squared equals r squared, where hk is your center and r is your radius. So you're going to see these two different ways. One where you actually get given the equation and it asks you for the center, so you just remember to change the sign on each of the terms following the x and the y. And then the radius, you just want to square root that 16 to give you 4. Something super easy like that. It could ask you to graph it. 1, 2, 3, 1, 2. There's my center. And then go up, right, down, and left your radius. And then make your circle. The other way that you could see it is maybe it'll give you the information like the center and the radius. And you, actually, let's make this negative, this positive, change it. Radius is, I don't know, 3. So I'd get x plus 3 squared plus y minus 2 squared equals 3 squared, which would be 9. And then the last way you could see it is if you're given the center and a point. So like negative 3, 2, point on it, 1, 4, let's say. And so for that, you're going to plug the center in as hk and the point as xy. So I'd get 1 minus a negative 3. 4 minus 2 equals r squared. And I'd get 4 squared plus 2 squared, 16 plus 4, 20 equals r squared. R would be square root 20 or 2 root 5, but if it just asked for the equation, it'd be x plus 3 squared plus y minus 2 squared equals 20, because that's r squared. So those are the 3 different ways you'll see circles, obviously minus the complete square way, which you've already done on your quiz. So test-wise, this would be what you could see for a circle. Okay, then came standard form of a parabola. Apparently I can't spell horizontal, so it's going to be wrong every time. Okay, there are 2 types of parabolas, ones that are horizontal, which point right or left. And this is a y minus k squared equals 4x minus h. So if the 4p is positive, it points to the right. If the 4p is negative, then it points to the left. Your vertex is hk still, and p is the distance from the vertex to the focus, and the vertex to the directrix. If it's vertical, now we're gonna point up or down. This is an x squared, so x minus h squared equals 4p y minus k. If the 4p is positive, it points up. If it's negative, it points down. But everything else here is the same. Vertex is still hk, and p is the distance from the vertex to the focus, or the vertex to the directrix. So again, like the circles, there's kind of 2 different ways to see this. One is you're going to get given the equation, and you've got to find the vertex, focus, and directrix, or they'll give you the vertex, focus, directrix, 2 of those 3, and you'd have to find the equation. So let's start with the first example where you have to find the vertex, the focus, and the directrix. Let's just say I've got y minus 3 squared equals 16x plus 2. Just by looking at this equation, because the y is squared and the 4p is positive, I know that this is going to point up. My vertex is negative 2, 3, and because 4p equals 16, p is 4. So if I were to graph this question, I would do negative 2, 3. There's my vertex. And we said this is counting up. So here's my vertex. My parabola is going to point up like that. My focus is 4 units up. 1, 2, 3, 4. Here's my focus, which is negative 2, 7. My directrix is 1, 2, 3, 4 down, which would be y equals negative 1. So if it was an x squared positive, I would point it to the right, still counting your distance of p in both directions. Okay, the other way that you could see parabola, well, one of two ways, is it gives you like the vertex and the focus, let's just say. And in a case like that, I would know vertex, I'm not going to plot on the coordinate grid, but negative 2 up 1, 2, 3. And focus 1, 2, 3, 1, 2, 3. I already know this points to the right, which means it's a positive 4p and a y squared. So I would get y minus k squared equals positive 4p x minus h as my standard form. My vertex can already get plugged in, so y minus 3, because that's k, equals, and then I'm going to come back and do the 4p, x minus negative 2 becomes plus 2. And then the other piece of information I would need is to count p's. So if I count from negative 2 to positive 3, my p is 5. So this would be 4 times 5, because that's 4p, and I get y minus 3 squared equals 20, x plus 2. You could also maybe be given like the vertex and the directrix. So if I do the same thing, still want to graph it 1, 1, 2, 3, 4. Here's my vertex. Directrix being y equals 2 means this is a horizontal line, and my directrix, my vertex points away from the directrix. So I know that this is an x squared with a negative 4p. I already have the vertex, so I can go x minus 1 squared equals, fill back in my 4p, y minus negative 4 becomes plus 4. And then I want to count the distance from negative 4 up to 2, which is 6, and this is 4 times 6. And it's negative because it's pointing down. So I get x minus 1 squared equals negative 24, y plus 4. So these could be given in any way, vertex, focus, vertex, directrix. You could even get focus and directrix where you have to find the middle point to get the vertex. But either way, you're going to get 2 of those 3 pieces of information. And then the goal is to get the equation at the end. All right, that was 9. 9.2 is ellipses. So the standard form of ellipse, remember there's 2 of them. If it's horizontal, that means it's wider than it is tall, okay? Then you've got x minus h squared over a squared plus y minus k squared over b squared equals 1. The a is larger, which is going to also be true for vertical. Vertical is y minus k squared over a squared plus x minus h squared over b squared. And really the order doesn't matter. These can be switched. What does matter again is that the a is the larger. So whichever term has the larger denominator determines if it's horizontal or vertical. If it's underneath the x, it's horizontal. If it's underneath the y, it's vertical. Okay, then center. This is true for both of them, HK. Once you get A and B, the A is equal to the distance from the center to the vertices. B is distance center to the co-vertices. C is the distance center to the foci. These are on your major axis, and this one's on the minor. And c squared equals a squared minus b squared. So remember, it's the opposite of the standard equation sign. The standard equation is plus for an ellipse, which means it's c squared equals a squared minus b squared. You will need to be able to find the vertices, the co-vertices, the foci, and then actually you don't have to worry about the eccentricity, although it is just C over A. You don't need to find that on the test. So you'll see these in two different ways. One is you'll be given the equation, something like x minus 2 squared over 4 plus y plus 3 squared over, let's say 16 equals 1. Here's my equation, and it could ask you for all those pieces of information. It could ask you for the center, which is 2, negative 3. Because the larger number is underneath the y, it doesn't always have to be first. The a squared is 16, and it's underneath the y. This makes this a vertical ellipse. So a is 4. B squared is 4, so b is 2. And c squared equals a squared minus b squared, which is 12. See what equals square root of 12, or 2 root 3. Okay, so now I've got all that information, and then it could ask you to graph it. So 2, negative 3 is my center. I said this is vertical, so the A is up and down. So I'm going up 1, 2, 3, 4, down 1, 2, 3, 4, and those are my vertices. 2, 1, 2, negative 7. Center I'm going to put down here too, because that's one of the things you're going to get asked. Okay. Your co-vertices are your B's, which are going right and left. Right and left 2. So co-vertices 0, negative 3, and 4, negative 3. I can draw my ellipse, and then to make the focus or the foci, it's on the major axis, which means my x is going to stay the same, but my y, I'm going to take and add and subtract 2 root 3. To graph it, because root 12 is not a whole number, I'm going to say it's in between 9 and 16, so it's in between 3 and 4. So 1, 2, 3, probably right there. Those would be your foci. So you can either get information like that, equate. Another way you could see a question about an ellipse is if you're given information about the ellipse and then it asks you either for the graph or for the equation. So let's say I give you that the vertices are 2, negative 3, and 2, 1. And the foci are 2, negative 2, and 2, 0. So again, like before, easiest thing to do is kind of just graph that so you can give yourself an idea of what it looks like. So you can have graph paper handy if you want. You don't need it, but you can. So it would be 2, 1, 2, 3. That's a vertex. 2, 1. x minus h. So the difference is a over b or b over a. Okay, so just like before, you can either get given the equation to find information or the information to find the equation. So let's do an equation first. X minus 3 squared over 25 minus y plus 2 squared over 4 equals 1. All right, so from the actual equation, there's so much information you can find just by looking at it. First of all, because the x comes first and the y is the one with the minus, this is horizontal, which means my branches are going to open right and left. The center, 3, negative 2. A squared is what's first, which is 25, making a 5. B squared is 4, making b 2. C squared is equal to a squared plus b squared this time, so c squared is equal to the square root of 29. So now if I wanted to plot all that information, again, you can have graph paper if you want it, but you don't need it because you can just kind of eyeball it. 3, negative 2, there's my center. Right and left the A because it's horizontal. So 1, 2, 3, 4, 5, which is negative 2, negative 2, and right 1, 2, 3, 4, 5. Not really proportional, but you get the point. I went right from 3, 5, which means this is 8, negative 2. Those are my vertices. The B is 2, so I'm going to go up 2. That's 3, 0. Down 2. That's 3, negative 4. I'm going to make the little box that passes through those. Make the asymptotes that pass through the corners. And because it's horizontal, I know that it's going to get flanked off the right and the left sides as close to the asymptotes without touching it. So the only other thing, so we said co-vertices were 3, 0 and 3, negative 4. The only other thing we could find is the foci and then the ellipse. Foci is on the major axis, which means I'm going to go from the center right and left root 29, which is bigger than 5 but less than 6. And if I just look at my center and I add and subtract it, this is coming to the x. So it'd be 3 plus and minus root 29, negative 2. And then the asymptotes, y equals k, which is negative 2, plus and minus, it's horizontal, so it's b over a, or 2 over 5, x minus 3. Okay, that's equation, and then get the information out of it. The other kind would be, let's say I give you information, and then you've got to find the equation. Okay, so let's say I've got foci, negative 1, 3, and 5, 3. So this is my foci. I know that my center is halfway. So if the distance here is 6, halfway between, or the midpoint is my center, I could just count it, or I could do negative 1 plus 5 over 2. And 3 plus 3 over 2. And 4 over 2, 6 over 2. As 2, 3, this point here. Okay, so there's my center. I know that it's horizontal. So I know it's an x squared minus a y squared, and that the x is going to get the a. I also know that 1, 2, 3, C is 3 because it's the distance from the center to the foci. Then major axis is 2A. So A would be 5. Now I've got A and I've got C. The only thing left to get is B. C squared equals A squared minus B squared. 3 squared would equal 5 squared minus B squared. And B squared is 16. So now I've got B is 4. There's my B. There's my C. If I needed the, well, I used that to get the other one. And the A is 5. For my equation, I really just need the center, the A, and the B. So X minus 2 squared, and I know it's X because it's horizontal, over A squared, which is 5 squared or 25, minus Y minus K, which is 3 squared, over B squared. B was 4, so this is 16, equals 1. If it had asked for the asymptotes, then I would say that it's because it's horizontal, it's B over A, so it's Y equals K plus and minus B over A, 4/5 X minus H. So just think again of the combinations of information that you can get for a hyperbola. You could get the center, and you could get you could actually get the foci and the vertices. You get the foci and the covertices. You could get the vertices and the covertices. Probably not going to be that easy because that's straight up your A and your B, but something along those lines. You could get major axis or minor axis, which would be the 2B. Okay, and then super easy, again, because we're not doing the rotation of the conics, just the classification of conic. You will have one question that's going to ask you to classify the conic. Remember, if A equals C, it is a circle. If A times C equals 0, this would mean one of the X's or the Y's is missing. This is a parabola. If A times C is greater than 0, so it's positive, this is an ellipse. And if A times C is less than C, which means, or less than 0, which means it's negative, then it's a hyperbola. Remember, A is what's in front of the X squared, and C is what's in front of the Y squared. So that should help you identify it. Again, that's a quick question. There's, I think there's 11 questions on your test. It's super important that you're joining from your phone for the Zoom call or your computer for the Zoom call, and you're using your iPad for the quiz. And I would access it through Safari so that you can upload your work at the end. Your work, you can split screen between Canvas and Notability, but my recommendation would probably be to do the hard copy of the work so that you can take a picture of however many pieces of paper that you need to upload for the work. All right, guys, good luck doing the review. Make sure you take your time, carefully do that review so that on the next time that we meet next week, I can go over questions that you're still unclear on, and then you're ready to go for your test. Have a great day.